This is AP Calculus, section 3.8, page 3. All right, our first problem, f of x is 2x squared plus 3x minus 7. Then I want to find f of 1, f prime of 1, f inverse of negative 2, and the derivative of the inverse at negative 2. So, since we're going to have to find a derivative, let's go ahead and find that right off the bat. So f of x is 4x plus 3. Great. Now, f of 1. Plug in a 1 in here, and we'll get 2 plus 3 is 5, minus 7 is negative 2. All right, if f of 1 is negative 2, that means that 1 comma negative 2 is on f of x, which means negative 2 comma 1 is on f inverse. Well, backing right out of this, that means then that f inverse of negative 2, which is the second one I asked you to find, that is 1. Perfect. All right, now, so we did those two, f of 1 and f inverse of negative 2. Now let's go find f prime at 1 and f inverse prime at negative 2. Well, f prime of 1, let's just plug in a 1 into here, that's 7. And f inverse prime, f inverse, the hazards of taking notes in pen. F inverse prime at 1, oops, not 1, negative 2, at the y value on the original function, which is the x value on the inverse, that derivative is the reciprocal of the derivative at the x value on the original function. 1/7. Done. Okay, we've pretty much satisfied our polynomials with inverses, but now we need to go ahead and we need to look at the inverses with some trig functions. All right, first I want to just kind of go back over some notation ideas about functions and trig functions specifically. So if we have this sine squared x, we know that that means the sine of x quantity squared. Yes? But sine negative 1, or inverse sine of x, is not sine x to the negative 1, which is 1 over sine x. Because 1 over sine x is cosecant, and that is not inverse sine. So this notation is not the same, and it works for just regular powers, but it doesn't work for the negative powers. And this is an ambiguity with this inverse notation. Old school notation looked like this. Instead of saying sine to the negative 1 almost, we said arc sine of x. That's inverse sine of x. So we didn't have to worry about that negative exponent ambiguity. We just saw this, arc sine, and that's an inverse sine. You need to know both notations, this notation and this notation for inverses. All right? Now, with that information, let's go ahead and let's find the derivative of the inverse sine. The derivative of the inverse sine. Well, we can't do this right now. What we can do, though, is to rearrange this, and if y is inverse sine of x, that means then that x is sine y. If that bothers you, then go back to something like this. You know the sine of pi over 6 is a half, which means inverse sine of a half is pi over 6. So I started right here, y equals inverse sine of x. So the half is like my x, and the pi over 6 is like the y. So then going up here to this line, sine y is equal to x. Okay, hopefully that cleaned that up for you. All right, now we can do a derivative, and we have an implicit differentiation in here. The derivative of an x is 1. The derivative of sine y, the derivative of sine, is cosine y. But then we have to multiply times the derivative of the inside. Remember, that's a hidden function of x. So times dy dx. Solving for dy dx, that is 1 over cosine y. And we have a bit of trouble here because our original function was written y equals blah, 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 x. That means we need to have our derivative in dy dx equals blah, 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 x. So we need to change this cosine y to x's. All right, to do that, let's go back to some of your pre-calculus and to what we started with. We started with x equals sine y. I'm going to write this as an x over 1. It might help you see that. If you turn it around the other way, then it says sine of y equals x over 1. Look what this is saying. Sine y. So y is the angle, and sine is opposite over hypotenuse. So from that angle y, opposite side is x, hypotenuse is 1. Then we can use Pythagorean theorem to find this piece down here. And this piece down here would be a square root of 1 minus x squared. All right. Now remember what we were trying to get rid of. We were trying to get rid of y. Well, I don't know what that angle is. What about cosine y? Can I figure out what cosine y is? Cosine is adjacent over hypotenuse. So from this y, the adjacent side, square root of 1 minus x squared, and the hypotenuse is 1. So let's just jot that down over here. Cosine y is adjacent 1 minus x squared over hypotenuse, or just the square root of 1 minus x squared. And taking that information right back over here, dy dx is 1 over the square root of 1 minus x squared. Oh boy, what did all that work tell us? All that work here told us that the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. The derivative of inverse sine is 1 over the square root of 1 minus x squared. Now, we could do this to find the derivatives for all 6 inverse trig functions. I'm not so sure that's worth our time. Let's just go ahead and write them all out so you have them all in one place. So, we have the derivative of inverse sine of u, and I'll explain that u in a minute. This is 1 over the square root of 1 minus u squared times the derivative of u. That's just demonstrating chain rule. It just shows to do a chain rule. So we do the derivative of the inverse sine part and then times whatever that inside is, whatever that inside function is. So this is the derivative of the inverse sine part, and then this means the derivative of the inside. Okay? The derivative of inverse tangent, u, is 1 over 1 plus u squared times the derivative of the u. The derivative of inverse secant is 1 over absolute value u square root u squared minus 1 times the derivative of the u. Okay, now the derivative of inverse cosine of u is negative 1 over the square root of 1 minus u squared times the derivative of the u. The derivative of inverse cotangent u is negative 1 over 1 plus u squared times the derivative of the u. And the derivative of inverse cosecant u is negative 1 over absolute value u times the square root of u squared minus 1 times the derivative of the u. Memorize. Memorize those, please. Really, there's only 3 of them that you have to memorize. These 3 right here. Those are the only 3 that you have to memorize, because what do you notice about the C functions? All of the inverses that start with a C are just the opposite of their respective cofunction. So cosine inverse, the derivative is the opposite of inverse sine. Derivative of inverse cotangent is the opposite of inverse tangent, and the derivative of inverse cosecant is the opposite of inverse secant. A couple other things that I use to help me memorize them is that a tangent looks like a plus sign. This would cover up the hook. So that tangent looks like a plus sign. It's the only inverse derivative that has a plus sign. Also, if there's a plus sign, there is no radical, no square root. As far as the difference between these two then, I think of secant being much more complicated than inverse sine. So its derivative then, I think of being more complicated, so it's got to have that absolute value of u. And if you use that absolute value of u, it has to be right next to the u squareds inside the square root. Those are just some of the tricks that I use to help me memorize them. You use whatever tricks you want to help you memorize them. Ooh, except for cheat sheets. Cannot use a cheat sheet. You need to use your brain to memorize them. If you want to use flashcards to help you, that's awesome, but you can't cheat. Thanks for tuning in. See you on page 4.